This video we're going to talk about the concentration time graph and also the average rate and instantaneous rate. So for concentration time graph, okay, in the textbook we have two, okay, this one and only this one, okay. So the one on the left hand side, okay, I add one more, okay. So this one is reactant time graph. We are talking about the change in concentration of the reactant. So basically, as a reaction proceeds, the concentration of reactant, it will drop. So for this one, for example, okay, as time goes by, the reactants, okay, will going down, and the concentration reach zero if the reaction have complete. So this one, okay, we are talking about a limited reagent. For limited reagents, okay, you will find that, okay, the chemical will finish using up, okay. But if the reagent, the reactant that you're talking about is in excess, okay, so that will be a reactant in excess. You'll find that at the end of the reactions, some of the reactant may left behind. So basically, if it is a reactant in excess, you'll find that it cannot touch the x-axis. It won't drop to zero. Instead, okay, it will go horizontal like this way. So basically, okay, we have two kind of reactant time graph. One will touching the x-axis, one will not touch the x-axis. But both of them, they will decrease, okay, as time goes by. But for the product time graph will be different because product in the process, okay, they're going to form. So therefore, on the other way round, okay, the product time graph, it will increasing as time goes by. But again, okay, if the reaction have complete, no more new product will be formed, so therefore it will go horizontal. So the y-axis, that will be the concentration, x-axis, that will be the time. So basically, there are three kinds of concentration time graph shown like this. So for concentration time graph, basically you have four things you have to pay attention to, four important points, okay. So I'm going to highlight in the graph. So the first one, okay, in a product time graph, you'll find that the concentration time graph, okay, it will be starting at zero, start at origin, because at time equals to zero, there is no product at all. So therefore, it must be touching zero. Second point, okay, it will be the end of reaction. Starting from this point onward, you'll find that all the point, okay, will be at the same with the same value of y-axis. So therefore, this point onward, okay, it means that no more reactions occur. So this particular point, F point, this F point, okay, that will be the end of reaction. So second point, end of reaction, where the reaction stops. So this end point, okay, we're going to draw two horizontal line, okay, one horizontal line, one vertical line. So this horizontal line indicated with this color, green color. This part, okay, shows the final concentration of the products. Okay, so this will be the final concentrations, and then the point, okay, hitting the x-axis, that will be the total time of the reaction. So basically, okay, there are 4 points you have to pay attention to. It must be starting at zero. There will be a point called end of reaction. After that, okay, the concentration won't change. For this point, we extend horizontally. We found the final concentration of the product, that is the total product that will form, and also we'll find the total time of the reactions that the reaction take place. Okay, so remember the total time is here, but not this point. Okay, this point is not the total time, because you see that we can infinitely to increase the time of the reactions. Okay, we can increase this part, okay, as long as we like, as long as we don't stop the reactions. So basically, okay, the point right here is meaningless. Okay, but the reaction end with this point, then this point will mark as the total time of the reactions occur. Beyond this, actually there is no reaction at all. So other than that, okay, we're going to talk about the average rate of the reaction. When we talk about average rate, okay, like previous, we say that we will talk about the change of product over time. So change of product, okay, it will be talking about the difference here from zero all the way to the final concentration of product. This difference, okay, will be the change in concentration of product. And then the time, okay, that will be the time from the beginning of the reaction at the end of the total time of the reaction. So this one will be the delta T, and then this one will be the delta P. Okay, so you can think of the math skills, okay, the 2-point form. Basically, you're looking for this 2 point, okay, the point here and also the point here. Okay, so by two-point form, actually you can find the average rate of the reaction. But actually the rate of reactions, we still have three different kinds. One is the average rate of reaction. We're talking about the whole reaction. So basically, okay, that will be the yellow point, okay, that we're talking about. The other one is average rate, okay, but this time they will indicate two particular times, say for example, x and y. So if this one is x, this one is y, we are finding the two-point form, okay, between these 2 points. So this one is also called an average rate, okay. So average rate at here and here, we can use these 2 points, okay, to find out the average rate. Okay, the third one is called instantaneous rate. Instantaneous rate, that means the rate at that particular moment. So we can random pick one point. Say for example, we talk about this purple one. Okay, so maybe pink. So this pink one, okay, at this point, okay, we want to know the rate at this point. If the rate at this point, okay, we say that will be instantaneous rate. So basically 2 kinds of average rate and 1 instantaneous rate. But how to find the instantaneous rate? We're going to do this way. So for instantaneous rate, okay, we need to have 2 steps to do that. First of all, we need to draw a tangent. Because just have 1 point, you can't find the slope. Is that right? So if you can't find the slope, okay, you have to create a tangent for it. So first of all, you have to tell them you need to draw a tangent at this point, and then, okay, you can find the slope of this tangent, and the slope of this tangent will be equivalent to the instantaneous rate. So right here, you can see that tangent, okay, at time equal to 0, tangent at time equals to t1, T2, this particular point, T2, T1, okay, and then we have T3. As time goes by, you see that the slope of the tangent, it is decreasing, okay, so this one's very important. Slope of tangent decreasing, okay, as time goes by, okay. So we can conclude that the tangent, okay, at time equal to 0, that means this point, that will be having the steepest slope. This point, okay, we have a name for that. This one is called initial rate. Initial rate actually is an instantaneous rate at time equals to 0. Okay, so when we talk about initial rate, okay, we know that we need to draw a tangent at 0 second, and then the slope of this one will be the initial rate. Okay, so initial rate normally have the highest rate because it is the steepest slope. Okay, you can see that it is the steepest slope right there. And the reason for that, okay, because at the beginning of the reactions, you know that, okay, all the concentration of the reactant, it should be the highest. Okay, because no reactant have reacted yet. So therefore, at this moment, concentration highest, the rate should also be highest. Okay, but as time goes by, you see that the rate, that means the slope of the tangent, decreasing as time goes by. Finally, if you have the reactions finished, say for example this point, okay, the reaction finished at this point. If I draw a tangent at this point, then you'll find that the tangent of this one, okay, the slope of this tangent will equals to 0 because the tangent is horizontal. So we'll say that, okay, instantaneous rate at end of reaction, it will be horizontal, slope will be 0. It indicates that the reaction stops, okay, at this moment. Okay, so just to remind you, okay, for a tangent, okay, when you have a curve like this, okay, when you draw a tangent, normally in exam they will show you the tangent, okay, they will draw a line for you telling that, oh, that is the tangent, okay. What you need to do is just to tell them how to determine, whenever the questions say how to determine the instantaneous rate at particular moment, then you have to instantaneous rate, then you have to say that there is 2 points. First of all, you have to draw a tangent at time equals to the time, okay, and the second one to tell them that the slope of this tangent will equal to the instantaneous rate. Okay, so basically this is the statement, okay, that you have to answer. Okay, normally it will be question like this, will be 2 marks for that. Okay, but when you really need to calculate, okay, the instantaneous rate, then for example you have a point like this. Okay, just want to remind you, when you draw the tangents, okay, try to, as far as possible, to have the line. Sorry, this one is not good. So you have, oh, this one is not good. Okay, because you see that it cuts 2 points, 1 point here, 1 point here. Is that right? So therefore this is not good. Okay, so this one is bad one. I use a pink one to show you one more time. So this one will be better. Okay, so this will be instantaneous. That will be the tangent for that. Okay, so when we go to a equal distance, okay, you'll find out the distance between the tangent and also the curve should be more or less the same. Okay, so everyone when they draw the tangent, okay, will be slightly different. Okay, so therefore you will have a range of answer for that. Okay, no worry for that. Just make sure your tangent doesn't cut 2 points. Okay, like what I've done for the blue one, this point and this one, then that will be a bad one. Okay, as long as the tangent just cut 1 point will be good enough. Okay, so that will be the tangent. Next, we're going to show you some examples. Okay, so right here we have calcium carbonate react with acid, and then they will give out salt, carbon dioxide, and water. And then the volume of carbon dioxide formed in the reaction was measured at regular time interval. So we are focused on the product here. Okay, so you can see that a product time graph shown here. So basically when you look at the graph here, so remember 0. Okay, so this point will be the end point of reactions, and then you have this one, the total product, and also this point. Okay, that will be the end of reaction. So roughly is 35. This one roughly is, this one roughly will be 75, I think. Okay, so after you take these data, okay, you can start reading the questions. Okay, for time interval 0 to 10th. Okay, so you're going to find 2 point form. So 1 point will be the 0 and 1 point will be 10. Okay, basically, okay, you will have this one, which is 56. Okay, around 56, about 56. Okay, right here, and then so therefore will be 56 minus 0. That will be the change in volume of carbon dioxide over time. That would be 10 minus 0 because just have 10 seconds. Okay, so for this one you can see that the unit, okay, will be cm cube per second. Okay, so that will be the first part. Second part, okay, that will be talking about the 10 seconds to 20 seconds. So for the point 10 seconds to 20 seconds, okay, so the readings here 20 seconds, okay, should be cutting at 70. So this one 56. So the second part, it will be 70 minus 56. That will be the change in volume of carbon dioxide, and the time difference will be 20 to 10, so therefore will be 10 seconds as well. So this will be the average rate between 2 points, okay, 10 second and 20 second. So last one, okay, that will be the whole course of reaction. Whole course of reaction, that means average rate from the beginning till the end of the reaction. So maybe I use red highlighter. So this point and also this point. Okay, so basically, okay, the difference will be 75 minus 0, 75 minus 0, and the time will be coming from 35 seconds minus 0. So the average rate, okay, roughly will be 2.14 cm cube per second. Okay, so this will be a typical questions for calculating average rates. We're going to talk about concentration time graph. Draw a tangent, okay, shows the initial rate. So basically you have to sketch a concentration time graph showing general change in concentration of reactant. So we have a reactant time graph. So if this one, okay, reaction until the reaction goes complete, okay, so we'll have a reaction time graph like this way. So remember the vertical will be the concentration of reactant, okay, and then the horizontal one will be the time. Do pay attention to the unit, okay. If you are told to have unit, okay, this one doesn't have, okay. If you have unit, then you have to say like per second, like mole per dm cube, things like that. Okay, so part A will be basically like this. Part B, you're required to draw a tangent to show the instantaneous rate at time equal to 0. So that is an initial rate. So you can find that, okay, we have a point as 0, and then we draw a tangent there. Okay, so this will be the tangents, okay, that you have to draw. Okay, so after you draw the tangents, okay, you can find the slope of this tangent, and then you can find out the initial rate. So what is the slope of the tangent when reaction has come to an end? Okay, when reaction comes to an end, that means here, come to an end. So the slope, okay, of this one have to be equals to 0 because the reaction has complete. Okay, so at the end of the reaction, tangent, okay, at this point will be horizontal, means the slope is 0. Okay, so therefore the reaction is complete. Reaction completes. Okay, so the concept it will be like that. So this red words here, it's just telling you that normally the slope, the tangent, okay, will be given by the questions. Okay, but in this case we didn't give in to you because we want you to draw ones, okay, on your own. So class practice 36.3, more or less the question is similar. Say for example, A corresponding instantaneous rate at A, B, C. Okay, calculate the corresponding instantaneous rate. So therefore you have to draw a tangent here, draw a tangent here, and then draw a tangent here. So basically for this one, tangents, slope of the tangent should be 0. This one have to be a highest. So you just find 2 points here. Say for example, you just roughly this point and this point, okay, using these 2 points, okay, you can find the instantaneous rate. And then for B, okay, you can have point here and point here, then you can find the instantaneous rate as well. Okay, so the calculation, it will be like this. So for point C, it will be 0. Just now we mentioned this one have to be 0. Okay, and then B, describe the change of rate during the course of reactions. So you notice that, okay, during the reactions, the reaction rate, okay, should be decreasing as time goes by, because as time goes by, the concentration of reactant drop, so therefore the rates will also drop. Okay, so basically at the beginning, start of reaction, rate is the highest. As the reaction proceeds, the rate will decrease. Okay, finally it comes to 0. So you can see that actually we have 3 points. Okay, at the beginning, during the process, and at the end of the reactions. Okay, so in the process, you just remember the rate of reaction will decreasing. So average rate of the whole course. Okay, we're going to pick 2 points. Average rate must be time equals to 0. This point, and also the end of reaction. End of reactions. So you just point out the total time should be 7. The total product it formed roughly will be 5.4. Okay, so 5.4 minus 0 over 7 minus 0. Okay, so this will be the average rate. Pay attention to the units that you have used. Should be mole per dm cubed over minute this time. Okay, so a few more examples, but all these actually more or less is the same. I'm not going to spend too much time on it. But this one, you just need to put the curve, put the graph on your own. So you have the concentration and time will be minute. Okay, you just put it right there. So just want to draw your attentions to part D. Okay, what you can tell about the change in instantaneous rate during the course. Again, okay, during the course, okay, that means as time goes by, instantaneous rate should be decreasing. Okay, bit by bit, decreasing bit by bit. So therefore, in this case, okay, we will find that instantaneous rate will decrease with time. So a few more examples, but the example is exactly the same. So you have questions similar, change in instantaneous rate during the course of the reaction. So basically, plot a graph, draw a tangent, find the slope, that will be initial rate. If you need an average rate, get 2 points. Okay, so remember the instantaneous rate, the tangent, okay, you just have 2 points throughout any point of this tangent. Okay, then use those 2 points. Okay, you can find the rate, okay, for that instantaneous moment. So in short, okay, summarize, okay, you learn that concentration time graph with 3 of them: reactant time graph, there will be the concentration of reactant will decreasing as time goes by. One will hit the x-axis because this one is a limited. One will it be in excess, so it won't hit the x-axis. And the other one is product time graph. For the product time graph, there are 4 points you have to remember. Start at 0, end of reaction, total product, and total time required. Okay, there are 4 points. Okay, instantaneous rate, you have to know how to describe how to measure instantaneous rate. There are 2 points. Okay, one, draw a tangent at that time. Second, slope of the tangent will equal to instantaneous rate. And the second terms, okay, we have learned, okay, very important, is the initial rate. Remember, initial rate, we're referring to the instantaneous rate at time equals to 0. Okay, initial rate, it must have in the highest rate. Okay, that is the steepest slope because at this moment the concentration is the highest. Okay, and the instantaneous rate at the end of reaction. Okay, the slope will be 0, the tangent will be horizontal because the reaction has stopped. Okay, so basically this is a concept of the average rate, instantaneous rate, and also concentration time graph. Okay, so that's all for this video. Bye bye.